Hi, hello there, and welcome back to Steamer with Steve. Today we're going to continue with our Dr. Frost homework, and this time we're going to learn how to factorize. So let's jump on in. So the question that we're going to face to start is going to look like this. So we're going to have to see how many, what number can go into both 16y and 20. So let's jump on in. So here's the homework sheet, the book that we've been using, and this one's title is Factorising. And we're doing this on the 5th of the 5th, 23. Highlight it so it's very clear for our teacher when we're coming through and marking it, and makes our life 10 times easier. Right, here we go. So question 1. First step, we write what's there. So we've got 16y minus 20. So the thing that can go into both of those is 4. So we take a 4 out the front, and we're left with 4y minus 5. Cool. Question number 2. 16p minus 12. So question number 2. 16p minus 12. So we can divide both of those by 4. So we take a 4 out the front, and we're left with 4p minus 3. Cool. Question 3, 16y plus 40. So question 3, 16y plus 40. Divide both of those by 4. So we can take a 4 out the front. Sorry, we forgot the equal sign as well for each one of these. So we take a 4 out the front, and we've got 4y plus 10. And then we should be looking at that going, oh, hang on, that can go even further. So we can divide actually both of those by 8. So we're going to cross that out. Take an 8 out the front. And we get 2y plus 5. Question 4. 28z minus 35. So we've got 28z minus 35. Divide both of those by 7. We're left with 4z minus 5. 18p plus 9. So here we go. Question 5. 18p plus 9. We can take a 9 out the front, and we're left with 2p plus 1. And we can always check these ones as well. So if you expand that, 9 times 2 gives you 18p. 9 times 1 gives you 9. So we're all good to go. Question 6. Let's see what we got. 28z minus 35. So the same as 5. 28z minus 35. Bonus question. Just to see if we got it. So 28z minus 35. We can divide both of those by 7. So take a 7 out the front. 4z minus 5. Done. Question 7. 27p minus 36. So we're going to go 27p minus the 36. We can divide both those by 3. Actually, we can go further. We can divide them both by 9. So we take the 9 out the front, and we're left with 3p minus 4. Question 8. Now we go a few more trickier ones. So question 8. We have 2x minus 10x squared. So we can take a 2x out of both of those. And we're left with a 1 and then a minus 5x. Question 9. Fourteen a minus 6a squared. So we can divide both of those two by 2a. So 2a at the front, and we're left with 7 minus 3a. Question 10. So we have 9a squared plus 15a. So both can take a 3a out the front. So we're left with a 3a plus 5. Question 11. $20a squared plus 5a. So you can take a 5a out both of the front. And you're left with a 4a plus 1. Question 12. 5p squared minus 5p. So we've got 5p squared minus 5p. So you can take the 5p out the front. Bracket p minus 1. Question 13. 7a plus 14a squared. So we can take the 7a out the front. Bracket 1 plus 2a. Question 14. 17p minus 17p squared. That gives us 17p out the front, 1 minus a p. Question 15. So we've got 10a squared minus 12a. So 10a squared minus 12a. I'm going to take a 2a out of both of those. So 2a, that leaves it with 5a there, and then minus a 6. Oh, hello. So we've got 13xy to the power of 5, z to the power of 4, minus 13xy to the power of 4, z to the power of 2. Here we go. So question 16. 13xy to the power of 5 minus z to the power of 4. Sorry, times z to the power of 4 minus 13x y to the power of 4, z to the power of 2. So that's going to have a 13 that's in common between both of them. Both has an x. Both have a y to the power of 4. And both have a z to the power of 2. That leaves in the first one no x's, one y, and then a z to the power of 2, minus no y, no x, no just 1. So it was just that. Question 17. 7pq minus 7p q to the p to the power of 4, q to the power of 3. So 7pq minus 7p to the power of 4, q to the power of 3. So both have a 7 in common, a p and a q. So it's going to leave a 1 at the front, minus no number, p to the power of 3, q to the power of 2. $18. Here we go. So we got 6a to the power of 3, b to the power of 3, c to the power of 2, plus 3a to the power of 3b, c to the power of 4. Well, we can take a 3 out the front. We can take an a to the power 3 out the front. Sorry, that should be a 4 there. We can take a b. And we can take a c to the power of 2. Just cross that, put that up there. And then that leaves us with a 2 no A's, a B to the power of 2, no C's, plus no number, an A, no B's, and we've taken a C to the power of 2, so then it'll be a C to the power of 2 left. Question 19. So we have 14 A to the power of 4 BC minus 6A to the power of 3 B to the power of 2 C to the power of 3. So we can take a 2 out the front. We can take an A to the power of 3. We can take a B. And then we can take a C. So that's going to leave us a 7A minus 3, taking an A, taking 1B, so then it's going to be left with a B, taking a C, so it's going to have a C squared. And question 20. One's a bit gnarly. So we've got 5 lots of x minus 5 all squared plus 3 lots of x minus 5. So x minus 5 is in common between both of those two terms. So you can rip x minus 5. So this one's a little bit trickier. So we've got 5 bracket x minus 5 all squared plus 3 lots of x minus 5. So I'm going to take an x minus 5 out the front. And then that leaves us with 5 lots of x minus 5 plus 3. So then we have x minus 5. And then inside I've done square brackets just to make it a bit more obvious. 5x minus 25 plus 3. X minus 5. 5x minus 22. Done. Cool. So the last question is a little bit more challenging, way outside the pay grade, but if anyone got it, that's really, really cool if you did. That's it for me. Hopefully you've learned how to factorize common terms and bring them out, so then you make the expression a lot more simple. If you do have any questions, please put them in the comments down below. And please don't forget to like and subscribe, and also hit that notification button so you can see when new content comes out. Thanks again. Hope you've enjoyed. See you next time on Steaming with Steve. Adios.